This video is a comprehensive review of 7th grade FSA standards for number sense and expressions and equations. So we're going to start off here with a problem that's referring to changes in temperature, which is essentially more about finding the difference between integers. The temperature drops, which of the following situations have a sum of 0? So got to be very mindful that whenever you're talking about situations where there's a sum of 0, what that basically means is that there is going to be two numbers that are the same distance from 0 on the number line. So if A is over here and B is over here, because A is going to be positive and B is negative, since they're the same distance, if they're the same distance from 0 on the number line, the sum of A plus B will always be 0 if those two numbers are the same distance. So now we have to read through this list and see which ones have that situation. So the temperature drops 15 degrees from 5 a.m. to 6 a.m. The temperature then rises 15 degrees from 6 a.m. to 7 a.m. So if the temperature drops by 15 degrees, that means it's negative 15. The temperature then rises 15 degrees, so that's plus 15. And so if we're looking at the sum of negative 15 plus 15, that will be 0. So this one would work. The temperature drops 14 degrees from 6 a.m. to 8 a.m. The temperature then drops 14 degrees from 8 a.m. to 10 a.m. Well, drops 14 is negative 14. Drops negative 14 is another negative 14. Those two do not add up. Those don't have a sum of 0. The temperature was negative 3 degrees at 4 a.m. The temperature then rose 3 degrees from 4 to 5. So temperature was negative 3 degrees, then rose 3 degrees. So that's plus 3. So negative 3 plus 3 will give me 0 again. Is not equal to 0 in this case. The temperature was 7 degrees at 11 a.m. The temperature then drops 7 degrees. So if we started at 7 degrees, that's positive 7. The temperature then drops 7 degrees, so that's negative 7. And so that's 7 plus negative 7. That will be 0. Temperature was negative 5 degrees. The temperature then dropped 5 degrees. So that's dropping is going to be negative 5 degrees. So that's not equal to 0. It's not equal to 0. The temperature was 10 degrees. Then it rose 10 degrees. So if it was already 10 degrees positive, then it rose 10 more degrees. That's 10 plus 10, which again is not 0. So altogether, we had that one worked, this one worked, and the A also worked. What two numbers are located exactly 3/5 units from 3/5 on the number line? And then which number line plots the location of these numbers? So to process this, we want numbers that are exactly 3/5 units from 3/5. So that means we're starting on the number line. 3/5 is a positive number. So if we started 3/5 at 3/5, so from 3/5, if we wanted to go 3/5 units from 3/5, well, then that would make sense to that one of the numbers should be 0, because from 3/5, if you go to the left by 3/5, you'll end up at 0. So then where would you end up if you went to the right by 3/5? Well, that would just be 3/5 plus 3/5, which is just going to be, the denominators are the same. That 5 is kept, 3 plus 3 is 6, so you should end up at 6/5. So now I'm just looking for the one that plots the location of these numbers. So I'm looking for a number line with 0 and 6/5, which would have been A. If you notice there's a distraction here where they'll show you that you have 3/5 and -3/5, don't fall for that distraction. Find the location of the number. So 3/5 minus 3/5. So 3/5 minus 3/5 will give me 0, and then 3/5 plus 3/5 will give me 6/5. Bruce claims that for any two integers r and s, the location of r plus s is to the right of r on the number line. Which statement best classifies Bruce's claim? So if you have two integers r and s, the location of r plus s is to the right of r. So what that must mean is that if I started with r and I added s, if it ended up going to the right, if I ended up going to the right, then that would just imply that the number that I added to r must be positive, because positive numbers go to the right. If you add a positive, you go to the right. So far, I'm going to check and see to say which statement best classifies Bruce's claim. Bruce's claim is never true for integers r and s. Well, that's not accurate. We know that if we added a positive number to r, we would end up going to the right of r. Bruce's claim is only true when r is a positive integer. Well, that's not true either, because even if r was -3, if I added 2, I'm still going to go 2 to the right of -3. So that's not true either. A is not true, B is not true. Bruce's claim is true only when s is a positive integer. Well, that makes sense, because in order for it to go to the right of r, s would have to be a positive integer if I'm adding it. So that's true. When s is a positive integer, it's going to go to the right if I'm adding it. Bruce's claim is always true for any integers r and s. That's not true, because if s was negative, then you'd have to go to the left. So this is just a matter of testing if you understand the rules for adding integers on a number line. Which expression represents the distance between -3 and 5 on a number line? So when we're talking about the distance between any 2 points, we know that that requires you to very simply take the two numbers and subtract them in any order that you want, and then take the absolute value. So I would have done -3 minus 5 and take the absolute value, or I could have reversed them and said 5 minus -3 and take the absolute value of that. So now I'm looking for the problems that demonstrate the same uh, expression on the number line. So I have -3 minus 5. If I take the absolute, if I solve this problem, that's -3 plus -5. Absolute value of that. -3 plus -5 is -8. So I need the absolute value of -8. The absolute value of -8 is +8. And then I have 5 minus -3. So if I keep, change, and flip the signs, that's 5 plus 3. The absolute value of 5 plus 3 is the absolute value of 8. The absolute value of 8 is, again, 8. So I'm looking to confirm that I don't have any expressions that end up being 8. So these two are not going to be true. That's going to end up being +2. So +2 here. -3 minus 5 is also not going to be +8. That's going to be -8. That's not true. And then again, I'm going to confirm that -3 plus 5 is not how you would solve this. You should have subtracted those, so that's wrong. And here we have the correct expression, -3 minus 5. Which of the following expressions is equal to negative 58? Select all that apply. So negative 14 plus negative 78 plus negative 34. So I'm looking for negative 58. Well, the way to confirm this is just to remember your rules for adding and subtracting negative numbers and just applying that and seeing if you get negative 58. So A doesn't make sense because if I have negative 14 and I add a negative 78, I'm supposed to add those two. Well, that takes me well beyond negative 58. And since negative 34 is more negative, I can't end up back at negative 58. So I didn't actually have to do the math to try to understand that one's wrong. I can also quickly eliminate F because 78 plus 34 is going to be a pretty large positive number. So if I take 14, which is not going to make it negative, F can't be the answer either. The rest of these are possibilities, so the only way to be sure is just to try them out. So negative 14, technically I have the right to try, well, to do these in the order I see fit, but negative 14 plus 78, that's going to be positive, let's see, 70, because the signs are different, I'm going to subtract them, so 78 minus 14 is going to be 64, and so 64 minus 34 will not give me negative 58. 34 plus negative 14, again, I have different signs here, so that's going to be positive 20. And if I do positive 20, and then I subtract 78, that does give me negative 58. 34 minus 78, so I do know that if I have 34 minus 78, I should just subtract them and then give a negative answer. So 78 minus 34 is going to be 44, and then so that's 44 minus 14, negative 44, because the 78 was more negative, negative 44 minus 14, and so now if I rewrite this, that's negative 44 plus negative 14, and so that would then give me negative 58. So that one works. For E, negative 78 minus negative 34 plus negative 14. So if I would probably have to do some more scratch work. So negative 78 plus, so if I subtract the negative, it becomes plus 34. And now I have negative 78 plus 34. The signs are different, so I'm going to subtract those. And that will give me, I'll rewrite it, plus negative 14. So that would be a difference of, again, 44, but it's negative 44, plus the negative 14, which is still here. And again, that will give me negative 58. So the key to this is just to try them out and use the rules for adding and subtracting integers to confirm that you have the right answer. So now we want to find the sum of these mixed numbers. 33 and 2/3 plus negative 40 and 1/3. Well, this one is actually pretty easy. You could rewrite these as improper fractions, but that's not really necessary because you actually probably should go ahead and rewrite them as improper fractions. Just because you're dealing with negatives now, and that can be a little tricky. So we're going to rewrite these as 31 2/3 plus negative 40 and 1/3. And so we're going to 31 times 3 is 93 plus 2 is 95 over 3 plus negative 40 times 3 is 120. 40 times 3 is 120 plus 1 is 121 over 3 And so we have the same denominator, so we're in good shape there. So we keep our 3, and now we just need to rewrite the numerators as 95 plus negative 121. And so in this case, there was no need to do any cross multiplication process, no need to find common denominators because you already had one. And so you could just keep the denominator and add straight across. 95 plus negative 131 is really just 131 minus 95, and then the answer is going to be a negative because a negative is larger. So that's going to be 11, so that's a 6. We have to borrow 1 here, so this becomes a 2. And then I needed to borrow 1 here, so that's 12. Minus 9 is 3. There's nothing left, so 36. But again, because the negative number was larger, it's going to be negative 36 over 3. And so at this point, negative 36 over 3 is going to be negative 12. So looking at the answer choices, then it looks like we did something wrong, which is why it's a good thing to do to have your work written out in case you make a mistake, because I made a mistake. For some reason, when I did the 121, when I rewrote it as 131. So very simple correction, 121 here, and that would now give me, instead of 131, it should be 121. And this is still going to be 11, but now this is going to be a 1, so then this is going to become 11. 11 minus 5 is 6, and 11 minus 9 is 2. So negative 26 over 3. So now 3 goes into 26, not 12 times. 3 goes into 26 8 times. So 8 times to be 24, and then there'll be 2 left over out of another 3. So there we go. So now we have negative 8 2/3. Very important teachable moment on showing your work so that if you make a mistake, you can go back and catch it. So which statement could be described as the product of 3 and negative 4? So we're looking for the product of 3 and negative 4. Well, product means multiplication. So the product of 3 and negative 4 would be 3 times negative 4. So 3 times negative 4, which should just be a result of negative 12. So at noon, the temperature was 0 degrees. During each of the next 3 hours, the temperature increased by 4 degrees. Well, if it increased by 4 degrees, that's not negative, that's positive. So that doesn't qualify. So you should see the negative 4 reoccurring 3 times if this is accurate. So this one does not work because this is increasing by 4 as opposed to decreasing. B, at noon, the temperature was 0 degrees. During each of the next 4 hours, the temperature increased by 3 degrees. So that means that you had 4 different hours where it increased by 3 degrees. So you added 3 4 times. So that's not it either, because that would be positive 3 times 4. That's not true. At noon, the temperature was 0 degrees. During each of the next 3 hours, the temperature decreased by 4 degrees. Well, that makes sense. So you had three different hours where it decreased by 4. So that's -4 3 different times. So that indeed would be 3 times -4. So this one works. The product of 3 and -4. At noon, the temperature was 0 degrees. During each of the next 4 hours, the temperature decreased by 3 degrees. So decreased by 3 degrees means it's -3. So we're looking at it does occur over 4 different hours. You do get -12, but which situation could be described as the product of 3 and -4? Well, only C, because this one is 4 times -3. So the numbers are correct, but does not have the correct signs. So the only answer here would have been C. Select all the values equal to -1/4. So here we learned that essentially when you're looking at equivalent fractions, dealing with the signs, if I have all my negatives, I'm going to count my negatives. So here there's only one negative. So this is essentially just going to be a -1/4. So -1/4 will not change. So I'm looking for the ones that are equivalent to -1/4. Well, here I have, for A, I have two negatives. If I have two negatives, that means that I'm going to end up having a +1/4. Here I have 1, 2, 3 negatives, so I'm going to end up having a -1/4 at the end of this one. So far, B is equivalent. I have two negatives here, so that's going to be, again, a +1/4. D, 1 over -4. That means I have one negative and an odd number of negatives will be negative. So that's, again, -1/4, which is equivalent. And here for E, I have two negatives. That means that I'm going to end up with a +1/4 here, which is not equivalent. So A, C, and D are not equivalent. B and E are the only ones that are equivalent. For the next one, I'm asked to find the product of -5/6 and -3/4. So we saw already that when you multiply two negatives, you're going to have a positive result. So first of all, I can eliminate C and D because those have negative results. Those can't be right. So from there, I'm just going to simply multiply straight across. Multiply my numerators. 5 times 3 gives me 15. 6 times 4 gives me 24. Since both fractions are negative, a negative times a negative will give me a +15 over 24. So my final answer is 15 over 24. So I want to double check to confirm, just in case they could have simplified this. And indeed, in this case, I can divide both of these, the 15 and the 24, by 3. That would have given me 5 over 8. So B is also accurate. So since A and B are equivalent fractions, those could have both been acceptable answers. So now we're going to convert this fraction to a decimal. And converting fractions to decimals is not difficult at all. All it requires you to do is just to complete the division. So if I have 3 over 11, so 3 over 11, I'm just going to write it as long division. So when you do this, you're going to put the top number in the house. So 3 goes inside and 11 goes outside. And as we've done in previous years, you will, in order to solve this, I have to add a decimal and bring it up because 11 cannot go directly into 3. So that I can add a 0 here. 11 goes into 30 now. That will be 2 times. because 11 times 2 is 22. So 22, difference of 8. Now I add another 0 and bring it down. And so that would be 80. And I had to bring another 0 down because 11 could not go into 8. And so 11 goes into 8 7 times. 7 times 11 is 77. A difference of 3 here. So now 11 does not go into 3. So I add another 0 and bring it down. And that gives me 30 again. So 11, because 11 goes into 30 2 times. And then 2 times 11 is, again, 22. And what happens here is I recognize a pattern. 0, bring it down, and there's 80. 11 goes into 80, again, another 7 times. So what you recognize at this point is that this is going to be 27272727 forever. So this answer then will be repeating 0.27. So it's 0.27 repeating continuously. And so that's represented by B. The 0.27 is going to repeat over and over and over again. So I'm going to choose B. Obviously, this is not right because it doesn't have a 0 in the ones place. This is not right because there should have been a 2 in the tenths place, and then D is just doing it in the wrong order. The 3 needs to go inside. Krista wants to paint her house. She buys 7.5 gallons of paint. She uses 3/5 of the paint on the front of her house and then buys 1.5 more gallons of paint. How many gallons does she have left? So we're painting the house. She buys 7.5 gallons. So she has 7.5 gallons. She uses 3/5 of the paint on the front of her house, then buys 1.5 more gallons. So this is just a series of operations to see if you can multiply and divide with and add and subtract fractions. So if I start with 7.5 gallons of paint, she uses 3/5 of the paint. So if she uses 3/5 of the paint, then that means that she's going to, we first have to find out what 3/5 is and then take that away. Or you can say, well, if she uses 3/5 of the paint, that means she has 2/5 left. So 2/5 of 7.5 would be 2/5 times 7.5. And so that's now going to require me to rewrite it as a mixed, as an 7.5 as an improper fraction. So 2/5 times 7 times 2 is 15 plus 1 is 14. 14 plus 1 is 15 over 2. So now 15 times 2, 2 times 15 gives me 30. 5 times 2 gives me 10, and 30 divided by 10 is 3. So now, when I use 3/5 of the paint, I have 2/5 left over, and the 2/5 of 7.5 is 3. So right now she has 3 gallons left over. Then she buys 1.5 more gallons of paint. So she buys 1.5 more gallons of paint. Then that means that she has 4.5 gallons left over. That's how you work that out. So as you can see, there's your answer, 4.5 gallons. Ben goes to buy some school supplies at a store. He has $30. You have your chart of the possible things that he could have purchased. He's going to buy a calculator. What combination of other items can Ben buy so that he spends exactly $30 in all? Okay, so he has $30. He's going to buy a calculator for sure. He's going to spend $17. That means that he's going to be left with $13. So basically what they're asking is, what combination of items can we buy to cost $13, exactly $13. So let's look at our options. We have a notebook and a pen. So if we bought a notebook and a pen, the notebook would have cost $12.50, which means it would have only had 50 cents left over. And so since nothing costs 50 cents, this pen is not 50 cents, that can't work. We'll get rid of that. 2 pencil boxes and a stapler. So $2.25, 2 pencil boxes. So 225 times 2 will be 450. And a stapler, and a stapler. So the stapler is $7, so plus 7, that's $11.50. That doesn't work. A notebook, a pencil box, and 3 pens. So a notebook is $12.50. Again, that's going to be too much. A pencil box, not a chance. So a stapler for $7, 2 pencil boxes, $2.25 each, and 2 pens. So the stapler was $7. 2 pencil boxes is 2 times 2.25, 225, and 2 pens is going to be 2 times 0.75. So that would leave me with 7 plus 2 times 225 is going to be 450 plus 2 times 75 cents would be $1.50. So it looks like, so 7 plus, if I add these two together, because they give me a nice even number, 450 plus 150 is $6, 7 plus 6 is $13. And so yes, that does confirm that a stapler, 2 pencil boxes, and 2 pens would give me $13. So it's really simple. All you have to do is just do the math and confirm that you could work with the operations. A farmer grew X pounds of rice last year. This year she grew 8% more rice than she grew last year. Which expression represents the number of pounds of rice that the farmer grew this year? So this year she grew 8% more. So last year she grew X, so X last year. This year she grew 8% more. So what is happening here is we have to know that there are multiple ways to solve this problem or to solve problems like this. But we started with X because that's what she got last year. This year, she grew 8% more. So X last year was 100% of what she grew. Then she grew 8% more, so plus another 8%. So whatever she grew last year was 100% plus 8%. So altogether, that would have been 108%. So last year's or this year's total will be 108% of X. So that's 100% of 108% if you divide by 100, or if you simply move the decimal twice, will be 1.08 times x. So 1.08x. And so our answer would have been 1.08x. 100% plus another 8% would be 108%. That's 1.08 as a decimal, and then you just multiply it by x to write the final expression. Ingrid is buying a pair of pants with an original cost of C dollars. The pants are on sale for 15% of their original cost. 15% off of their original costs. Which two calculations could Ingrid perform in order to find the amount she needs to spend? So she the original cost was C dollars. 15% off can be looked at as in two ways. So if we're looking at, again, the original cost will be 100% of the cost. If she takes 15% off, that's minus 15%, and that would be 100% minus 15% would be 85%. So 85% of the original cost. So 85% of C. So that's, again, if you divide this by 100, that would be 0.85 times C. So 0.85 C. That's one way that you could have done it. Or you could have simply said 100% of C minus 15% of C. And so 100% of C would just be C minus 15% of C, which is 0.15 C. So C minus 0.15 C is the other way that you could have found it. So in both cases, well, those two answers are represented by answer choice C. A is wrong because you're adding the 15%. B is wrong because, again, you're adding the 15%. C is, oh, okay, let's make this correction. Here's the issue with C. This is actually not right, which is why it's always important to go back over your answer choices. C is not right, because if you look, to find 15% of C is 0.15 times C. This does not multiply by C. This only has 0.15, so that's wrong. When you look at D, it's C minus 0.15 C, and that one is correct. Very important to always go back over your work to confirm that you picked the right answer. Maggie is buying a jacket. The expression shown represents the sales tax on the jacket, price J. Write an expression in terms of J to represent the total amount that Maggie spends on the jacket, including tax. Okay, so if you think about it, when you pay for a jacket, you're going to pay for the jacket plus the tax. The jacket's price is J plus the tax. What they just said, that the expression shown represents the sales tax. So this expression is the sales tax. So that'll be J plus 0.08 J. So I can write it as J plus 0.8 J, or because these are both J's, I could very simply say that this is one whole J. So if I thought about this as one whole J, that'll be 1J plus 0.8 J, so that'll be 1.08 J. I'm combining the like terms because they have the same final variable in this problem. So I could have done it in either of these ways. I could have done this, and I could have done that. Which expression represents that X was doubled and then decreased by 25%? Doubled and then decreased by 25%. So I start with X and I double it. So if I do what they asked me to do, X was doubled, that would have been 2 times X, and then decreased by 25%. So if I'm decreasing by 25%, it's always important that you know that this is 25% of X. 25% is not a standalone unless you have a number that you're working with or a term, a quantity that you're working with. So it's decreased by 25%. So decrease is going to be subtraction. So that's 2 times x, and then subtracted by 25% of x, which is 0.25x. So 2x, 2.2 times x minus 0.25x is my expression. 2 times x is 2x minus 0.25x. So that's one way that I could have written it. That's represented by A. So let's confirm that there aren't any other correct answers. So we have 0.25x minus 2x. Well, that's not true because you're not decreasing by 2x. 2 times x minus 0.25x, that's not true. This would be taking 25% off first and then doubling the answer. That's not true. Here you're starting with 2x minus 0.25. No, because here you are going to be, you're doubling x again, so that's not right. The only answer here is A. So which expression is equivalent to m minus 0.25m? So again, we're looking at equivalent expressions, and so if I have m minus 0.25m, since they both end in m, I have the opportunity to combine the like terms. And remember, I can always think of m as 1m. So this really means 1m minus 0.25m would just be 1 minus 0.25 and then put the m back. So 1 minus 0.25 if I put the m back would be 1 minus 0.25 is 0.75 m. So 0.75m is 0.75 times m. 0.25 times m is not right. 0.25 less than m, based on the original expression, is correct. 0.25, well, 0.25 less than m, no, because you'd have to have 25% of m, or 25%. Yeah, no, these wouldn't be accurate. 0.75 less than m, no. The only one that makes sense is 0.75 m. And clarification, which expression? Singular, only one correct answer. So we're in good shape there. Sam's fruit seller earns 40 cents profit for each apple that it sells and 40 cents profit for each banana that it sells. Which expression shows Sam's total profits from selling apples, A, and bananas, B? Select all that apply. So they gave us information, 40 cents profit for each apple and 40 cents profit for each banana. Which expression shows the profit for selling apples and bananas? Well, every time I sell an apple, that would have been 40 cents times the number of apples. So times the apples plus I'm also going to make 40 cents times the number of bananas. I'm then going to simply rewrite it as 0.40 times the number of apples plus 0.40 times the number of bananas. So that would then mean that I could, from here, I have 0.40A plus 0.40B. That is a correct way to represent it. And I have that here as option C. But then there are other options to consider. And you'll notice that you have parentheses involved in some of these, because it is fair game for you to recognize that since both of these are 0.40, I technically can rewrite this as 0.40 times A plus B, because every time I sell apples and bananas, I'm making 40 cents on every one. Since the profit is exactly the same, I can just find out how much apples and bananas I sell altogether and then multiply that by 40 cents. Because again, in both cases, I'm multiplying by 40 cents. If the numbers were different, if the profit was different, I could not do that. But in this case, since the profit is exactly the same, I could add A and B first and then multiply by the 40 cents. So B here does work. A is not right because you're not multiplying the apples by the bananas, you're adding them. D is not right because you have to multiply the 40 cents times A and not add 40 cents plus A. Here is not, E is not right because you're not adding 40 cents and 40 cents. You're multiplying 40 cents by the sum. So in these cases, you should not be dealing with 0.80. And that's it. So B and C are the only correct answers. The expression 8x plus 12y represents the sum of Harry and Mike's total monthly wages, where x represents the number of hours Harry worked and y represents the number of hours Mike worked. What is another way to write the expression? And what can you conclude from rewriting it in this way? So we're looking at what's another way to write the expression. So we're talking about 8x plus 12y. How else could I write this expression? Well, this comes down to the idea of being able to pull out a common factor and really just being able to reverse distribution. So when you look at all of these, you have the parentheses, which means that you are supposed to technically distribute the number on the outside to the number on the inside to determine if they are equivalent. So if I do the distributive property with each of these, that's 8 times x and 8 times 1.5y. So 8 times x plus 8 times 1.5y, and that will give me 8x plus 8 times 1.5 is going to give me 12y. And that takes me back to my original expression. So this one does work. Now, and actually before I choose that as a final answer, let's confirm something. So far the expression works. Because Harry's hourly wage is 1.5 times Mike. Well, let's see, can we really say that? Not really. Let's come back to that conclusion. So far, this one might be right. B. Again, I have 8 times x plus 8 plus 1.5 times y, same thing. So this one might be right. 12 times the 8x, no, because that would give me 96x. So that's not right. 8 times x plus 4 times y. 8 times x is 8x, but 8 times 4y is 32y. So that's not right. So we have to look at these two, A and B, to determine or to see which one is. So we're told here that Harry's hourly wage is 1.5 times Mike, or Mike's hourly wage is 1.5 times Harry. Well, let's walk back and see what information they give us. So we have X represents the number of hours that Harry works. Y represents the number of hours that Mike worked. So if Y is the number of hours that Mike worked, and that's being multiplied by 1.5, so Y is multiplied by 1.5, and that's Mike. So that means that Harry's hourly wage, so in order for them to be equal to the same number, Harry's hourly wage is 1.5 times Mike's, because Mike was Y. Harry was X. So if Harry is X, and Mike is Y, then I can safely say that A is the correct answer, because I'm multiplying Mike's salary by 1.5 to get what Harry got. Okay? So A is my final answer. Tina and Tammy both get paid equal hourly wage of $12 per hour. This week, Tina made an additional $46 in overtime. So let me equals the number of hours Tina worked this week, and Y equals the number of hours Tammy worked this week. So if we are processing through this, we're looking for the expression that represents the weekly wages of both, if X is the number of hours that Tina worked. So Tina and Tammy both get paid an equal hourly wage of $12 per hour. So $12 per hour for both. All right, so that means that if I'm always going to find out how much they got paid by multiplying the $12 by the number of hours. So for Tammy, it would be 12. So 12 times X for Tina, and 12 times Y for Tammy. And so if we're looking for Tina making an additional $46 in overtime, that means she made additional $46. Tina was X, so that would be 12X so 12X plus the $46. So that's one way to look at it. And then you have, we're looking for the wages of both. So wages of both is going to be a total, which means that you're adding them together. So 12X plus 46 plus 12Y. So that's one way to do it. And that's represented by choice B. But if you notice, 12X and 12Y, I could rewrite those next to each other. Plus 46. I do have the right to rearrange the numbers because it's all addition. And when I look at it this way, I recognize that 12X plus 12Y plus 46 is written here. But now I can see that these X and Y have the same like term of 12, same coefficient. So I could rewrite this as 12 times X plus Y. Because if I distributed it back, that will give me 12X plus 12Y. And my 46 is still here on the outside by itself. So that's why D would be an appropriate answer. A is not appropriate because you're subtracting Tammy's salary. That's not accurate. C is not appropriate because, again, you're subtracting the salaries. You just want the total number of hours. E, I could technically do this because that is the scenario here. Here's Tina's salary plus Tammy's salary. So this one could work. And this one is incorrect because I am going to be, I'm finding the difference in this case, and I don't need the difference. They ask for an expression that represents the weekly wages of both. They didn't ask for a comparison, they didn't ask for the difference, they ask you to combine them. So that leaves B, D, and E as the final correct options. So select the expression here that is equal to 9x plus 3 minus 5x minus 7. Well, then in this case, what I'm going to do is when you have an expression that has a subtraction sign on the outside, in this case right here, what I need to do is, let's just say, as we normally do, keep, change, and flip the signs of the expression. So I'm going to leave 9x plus 3 alone. I'm going to rewrite subtraction as addition. And then I'm going to put the negative with the 5x minus 7. Why am I doing that? Because now I can put a negative 1 right here, because when you have a negative quantity and you don't have a coefficient, so this parentheses says that I could put a coefficient here to multiply, like we do with the distributive property all the time. So since there was nothing there, a negative without a coefficient is going to be a negative 1, just like a x without a coefficient is 1x. So I can put a 1 here now. What that allows me to do is I can distribute the negative 1 without confusing myself. So now I would have, if I just focus on the distribution over here, negative 1 times 5x plus, when you distribute, you're going to keep the sign to the left and go ahead and distribute, plus negative 1 times negative 7. And I'm only putting the negative 1 in parentheses just to remind us that it's multiplication. That's not anything significant. So negative 1 times 5x, negative 1 times negative 7. And since I didn't do anything with the 9x plus 3, I'm going to bring that down. So now my plus sign is still there. I haven't done anything with that. That's going to help to eliminate some confusion with this. So now I'm going to go ahead and combine or do my multiplication. Negative 1 times 5x is negative 5x plus negative 1 times negative 7. Two negatives make a positive 7. And again, I haven't done anything with the 9x plus 3. So I'm going to bring that down. My plus sign is still there. So 9x plus 3 plus negative 5x plus 7. So now I'm going to focus on the fact that I can combine these like terms, because I would have normally put this parentheses here. But since I don't have anything else that needs to be separated, I'm not confused, my signs are all properly connected, everything has an operation and a sign, the the parentheses don't really serve a point here. So I'm going to get rid of the parentheses. So that means now I can combine my like terms. So I have x's and I have constants or numbers. So if I made columns to combine them, I have x's, I have 9x's, and I have negative 5x's. In my numbers column, I have 3 and I have 7. Because I keep all my signs that are to the left, and this makes it very easy. So now I can see if I combine 9x and negative 5x, 9x plus negative 5x will be positive 4x. 3 plus 7 will be 10. So I can rewrite that as 4x plus, because everything is being added, you can see here I made sure there was an addition sign between everything, 4x plus 10. 4x plus 10 is my final answer. So what did I do? I rewrote the subtraction as adding a negative. I put a 1 in front of the parentheses as a coefficient. I distributed the -1 now so that I could have that expression free. Here, if I put a 1 out here anyway, it still turns out to be 9x plus 3. So that's why we got rid of the parentheses. And then I noticed that my x's go together and my constants go together. And that's how I determined what to combine. And after I combine them, 4x plus 10. And that's it. Which of the following expressions are equivalent to 18x plus 12 minus 4? And we need to select all that apply here. So if we have 18x plus 12 minus 4, again, we can say, okay, I have x's and I have numbers. So if I have 18x's, it's going to go on the x column, 12, and I have minus 4 or negative 4. So I'm going to put negative 4 in this column. So that's going to be, if I total them up, 18x by itself, and then 12 minus 4, 12 plus negative 4, is 6. I'm sorry, 8. So I'm just going to add them back up. So 18x plus 8. So that is answer choice C. Now, what I cannot do is try to combine 18, 12, and negative 4. I cannot do 18 plus 8 because they don't have the same ending variable and exponent. So that does not work. 30x minus 4, that would be trying to combine 18x and 12, and you can't do that because they don't have the same variables. Now, let's look at these other ones. 2 times 9x plus 4. So would it work if I did the distributive property, if I multiplied 2 times 9x and 2 times 4, would I get 18x? Well, 2 times 9x is 18x. 2 times 4 is 8. So yes, I would get, and we'll just go ahead and write it out. 2 times 9x plus 4. The distributive property allows you to multiply the term on the outside by all the terms on the inside. So 2 times 9x plus 2 times 4. 2 times 9x is 18x. 2 times 4 is 8. So 18x plus 8 again, so that works. So D is accurate. And at this point, I look at the next one. I have parentheses here, but before I try to work with the parentheses, I'm going to go ahead and say, well, I have 12 minus 4. I know 12 minus 4 is 8. So if 12 minus 4 is 8, that means I end up with 2 times 9x plus 12 minus 4. That's 2 times, if I combine these two, it's 9x plus 8. Well, if I already had 9x plus 4 as an equivalent expression, it's not likely that this is, but just to confirm, 2 times 9x plus 2 times 8, that's 18x plus 16, which is not what I was looking for. My focus is 18x plus 8. So this is not right. And then the last one is just a matter of just trying it out. 6 times 3x plus 2 minus 4. So again, if I distribute it, and it's important to remember, distributive property only applies to the items that are directly attached to parentheses. So I would not distribute the 6 to this 4. So 6 times 3x plus 6 times 2. And I want you to note that when I'm doing these problems, I'm interchanging the dot here with parentheses because they both mean multiplication. So here's 18x plus 12. I still have my minus 4. So I bring down my minus 4 again. So now we're back at, if I have my like terms, 12 minus 4 here, I know that that should have been 8 from the beginning. And I bring down my 18x. So there's 18x plus 8 again. So this one was actually right. So the only way to really confirm if they're equivalent is to do the math. All right, so we're able to see that there were 3 answer choices that were actually equivalent. As long as you know that you cannot combine variable terms with constant terms, and you have to combine variable terms if they have the same exact variable exponent combination or the same last name, you'll be fine with those. So select the expression that's equivalent to 8.4x plus 2.9 plus negative 3.7 plus 5. Okay? So now we're dealing with rational numbers, decimals. And so in this case, since I have a plus sign, since it's only addition, I really don't have anything to be worried about. There's nothing that is stopping me from rewriting this expression because there's no need for the parentheses here at all. There's nothing outside of it that needs to be separated. So I can really just rewrite this without the parentheses. 8.4x plus 2.9 plus negative 3.7x. That parentheses only separates the plus from the minus, from the negative sign, plus 5. And combine my like terms. I have x's here, and I have constants here. So if I have a column for my x's and a column for my numbers, it's 8.4x, negative 3.7x. And then I have my number column would be 2.9 and positive 5. So if I combine them, 8.4 plus negative 3.7 or minus 3.7 would give me, that's 14, 7. So 14 minus 7 is 7. Then this became 7 minus 4. Bring a decimal straight down, and that's 4.7 x's. So 4.7x, 2.9 plus 5 would be, line up my ones place. So 2 plus 5 is 7. So 7.9. So when I rewrite it, it would have been 4.7x plus 7.9. So 4.7x plus 7.9. So this one works out okay. I look at the others, and none of them have any reason for me to consider them as options. And so that's it. 8. Select the options that are equivalent to 4 times 3x plus 3. So again, looking at the distributive property, most likely, so 4 times 3x plus 3, distribute, that's 4 times 3x plus 4 times 3, that's 12x plus 12, okay, there's that one. So now I'm going to look and see, are any other ones equivalent? Well, if I take B, rewrite B. So here the key is to go ahead and just rewrite them to see which ones are equivalent. So 2 times 6x and 2 times 6. 2 times 6x is 12x. 2 times 6 is 12. So again, that works. So 4 times 3x plus 3. Well, this is not distributive property because this 3 is not, this second 3 here is not inside the parentheses. So this is 4 times 3x, which is just 12x's, plus 3. That is not equivalent. D, if I have 3x plus 3 plus 3x plus 3 plus 6x plus 6. I have x's. I have numbers. So if I make my boxes, I have an x column, and I have a number column. I have 3x, another 3x. I have a 6x. Those 3. In my number column, I have a 3. I have another 3, and I have a 6. So 3 plus 3 is 6. 6 plus 6 is 12. So 12 x's. 3 plus 3 is 6. 6 plus 6 is 12. So it's 12x plus 12. And that's what I was looking for. So this one actually does work. So here I have 12x times 4 plus 3. 12x times 4 plus 3. So 12 at 12 times x is 12x times 4 plus 3 is only 7 because it's in parentheses, so I'm going to do that first. So 12x times 7, that doesn't help me at all. So that's crazy. So that's wrong. So that's that. So only A, B, and D were accurate. Which expression is equivalent to 1/4 x? 1/4 times a difference of x and 2 plus 1/3 x. All right. So in order to do that, I need to rewrite this. So I have 1/4 times x minus 2 plus 1/3 x. So again, since I have a number outside of parentheses, I will need the distributive property. And that will leave me with 1/4 times x. And when I'm going to distribute, I'm going to keep the sign to the left and use addition in between every time. Because remember, this is x plus -2. So plus 1/4 times -2 plus the 1/3 x, which is still here. That came straight down. So this is 1/4 x is 1/4 x plus 1/4 of -2 is going to be -1/2 because 1. So if I put a 1 in the denominator like we've done before, 1 times 2 is 1 times -2 is -2 over 4 times 1, which is 4, plus 1/3 x. So now, this is, like I said, really -1/2, but I have x's that have the same variable combination. So if I was to combine those, 1/4 x plus 1/3 x plus my -2/4 is going to become -1/2. Now I have to add fractions that have different denominators. Well, I know I have a common denominator here of 12. And I know I need to keep my x there. So to rewrite 1/4 as a denominator, as a fraction with a denominator of 12, I have to multiply with 3. So times 3 in the top and bottom. So that will be 1 times 3, which will give me 3, plus times 4 to get 12 here. So 1 times 4 will give me 4. My 1/2 is still coming down. So that's 7/12 x plus -1/2. And so what you'll see is that that's just 7 over 12x minus 1/2. 7/12x minus 1/2. Because adding a negative is really just subtracting. Minus 1/2. And there we go. Making sure that all of our signs are right, and yep, we're in good shape. What is the result of 3/8 x plus 2 1/5? What happens when it's subtracted from 3.5 x minus 4 1/10? Well, you're looking at a situation where you have to just do it to figure it out. So I'm just going to rewrite 3. So if we're subtracted from, that means I'm starting with this expression. So 3.5 x minus 4 1/10, sorry. And you're subtracting 3/8 x in parentheses plus 2 1/5. And we put it in parentheses because this entire expression is being subtracted from this entire expression. That's all that means. So if this whole thing is being subtracted from this whole thing, put them in parentheses first to give you a guide as to how to work. As we went over previously, if I think about this as adding a negative, and I put a 1 right here, that's plus -1 times this, then that reminds me to distribute the -1. Now remember, when you multiply by a negative, you're basically just changing the sign. So that would be 3.5 x minus 4 1/10 plus negative 3/8 x plus negative 2 1/5. And what that is going to require that we do is to, again, combine my like terms. So I have my x's, and I have my numbers. I have 3.5 x's, and I have -3/8 x's. Then I have -4 1/10 as a number, and I have -2 1/5 as a number. And so now I'm being asked to just combine those. So that's just more scratch work, but what I can see first of all is if I take 3.5 and I only take away 3/8, that's not going to be -3 1/8. That was not right. I can safely also say -4 1/10 plus -2 1/5 is not going to give me a positive result because I'm adding two negatives, so that means that B is wrong. And then from there, I also can technically, without doing the math with the x's, can see that if I'm adding two negatives, 4 plus 2 is not, -4 plus -2 is not going to give me -2. So I can see that that one was wrong. And so really, once I set the problem up, I was able to identify the correct answer without actually doing anything with the common denominators and things of the sort. So my answer would have been C. So what is the sum of the two expressions that are given here? So let's move on to the next one. Let's focus right here. So what is the sum of the two expressions? So again, because there's only a plus sign here, this parentheses really doesn't serve much of a purpose other than to say that they originally started together. There's no special numbers, no negatives or anything like that. So what that allows me to do is really just combine my 2/5 x and my 1/5 x. And we should start to get to a point where in our heads we can see that that would just be 3/5 x. I also plus, I have the 3 and I have the -1. So if I had the column off to the side, I have my x column, and I have my number column. I have 2/5 x and 1/5 x, and I have my 3. And here, again, this is a -1 because I keep my sign that's to the left, because that's really adding a -1. So, like I said, again, you add these together, you should have been able to see that I was 3/5 x plus 3 and a -1 should have been 2. So when I put those together, that's 3/5 x plus 2. It's really that simple. Find the difference of the two expressions. Okay, so now, remember, this just requires a little bit of setup work. I think of this as adding a -1 here. So if I do that again, now I'm going to distribute the -1. So if I distribute the -1, that's going to give me 2/5 x plus 5 plus, well, I'll do it underneath. I'll rewrite it as 2/5 x plus 5 plus, when I distribute the -1, that's -1 times 1/5 x plus -1 times -3. So at this point, all I'm doing is really just changing the signs. So that's 2/5 x plus 5 plus, I'm changing the sign, -1/5 x plus changing the sign, 1 times 3 is +3. Now again, if I have my x column and my number column, I have 2/5 x, I have -1/5 x this time. I have 5, I have 3. So if I put those together, 2/5 x plus -1/5 x, which is 2 minus 1, which is going to be 1/5 x. I'm going to come up here and keep working. So 1/5 x, and then 5 plus 3 is plus 8. So my final answer would have been 1/5 x plus 8.